Hi, we're going to introduce some properties of numbers, prime numbers, composite numbers, and relatively prime numbers in this video. So first thing is, a prime number has exactly two factors. Now, factors are numbers that multiply together to make another number. So some examples of prime numbers would be like 2 would be prime because the only thing that multiplies to make 2 is 1 times 2. Key is the only thing that multiplies to make 2 is 1 times 2, nothing else. Same with 5 and 17. There's only one pair of numbers that multiply together to make 5. It's 1 in itself. And 17, the only thing that makes that is 1 and itself. So a number is prime if nothing goes into it except for 1 and itself. Now some non-examples, some things that are not prime would be 1. 1 is not prime because it only has one factor. And prime numbers have exactly two factors. 1 is just 1 times itself. It's 1 squared. You can't count the number itself twice, so it's just 1. Another non-example would be 12. 12 is not prime. 12 is what's called composite. 12 is not prime because it's got several factors. It's got more than 2. It's got 1 times 12, it's got 2 times 6, and it's got 3 times 4. That's more than 2 factors, so it's not prime, it's composite. Okay? Now, in case you haven't picked it up yet, composite numbers, they are numbers that have more than 2 factors. Some examples would be 8. 8 is composite because 1 times 8 is 8, and so is 2 times 4. So here's 2 factors, there's 2 more, not prime, composite. 10 for the same reason. 1 times 10 is 10, and so is 2 times 5. Here's a non-example is 1. 1 is not composite because 1 is 1 times 1. That's just, you can't recount the same number, so it's 1 factor. Another non-example would be 29. 29 is not composite. The only thing that goes into 29 is 1 in itself, so it's prime. Okay, so these are just things you got to know. Now, let's talk about how can you tell, how could you determine if a number is prime, a number, that's not hashtag, determine if a number is prime or composite. So let's talk about, let's say 27. So what you got to do to determine if the number is prime or composite is you have to factor it. You have to break it down into smaller pieces that multiply to make 27. So 1 times 27 is, of course, 27. And if that was the only pair of numbers that multiplied to 27, if that was the only factors, then it would be prime. But 3 goes into it 9 times. So it is composite. Sometimes the numbers are a little bit trickier. But there's some giveaways, there's some clues. So for example, like let's say any number that is even, 4297160. Do you see how it ends in an even number? That means it's composite because 2 goes into this. So for sure, we got one factor that's 1 times itself, which is just ridiculous. And then 2 times another, it's like, I would have to divide it by 2. I don't have a calculator with me. I don't want to do it in my head. Anyway, 2 does go into this. So this would have more than one factor, or more than 2 factors, and so this is composite. Another way you can tell is if the number ends in 0 or 5, that means that 5 divides into it. Since more than 1 in itself divides into it, 1 times itself, since also 5 would divide into it, that's more than 2 factors, so it would be composite. Another way you could determine if a number is prime or composite is, well, if 3 divides into the number, then it won't be prime because it'd have more than 2 factors. So the way you can see real quick, let's do 1, 2, 5, 7, 9, 0. The way you can see really quickly if 3 goes into a number is you can add up all of those digits. 1 plus 2 is 3, 8, 15, 24, plus 0. So all of those numbers add up to 24. 3 goes into 24. So 3 goes into this. So therefore, it's composite. Also, it's composite because it ends in 0, which means 5 goes into it. Also means that 2 goes into it. So, to back up, to review, the way you can tell if a number is composite or prime is if another prime number goes into the number you're dealing with, then it's composite. So like, let's talk about 97. 2 doesn't go into 97, it ends in 7. 3, well, 9 plus 7 is 16. 3 doesn't go into 16, so 3 doesn't go into that. 5 doesn't go into it because it doesn't end in a 0 or a 5. Now there's shortcuts for 7 and 11 and some of the others, but it's easier just to divide. So if you had to figure out if this was composite or prime, hopefully you would have a calculator and you would just do 97 divided by 7 and then 97 divided by 11 and 97 divided by 13 and so on. These are all prime numbers right here. And if nothing divided into it, then you would be good to go. It would be prime. Okay? So one thing might be a good idea is Google's your friend. I would Google lists of primes from 0 to 100 and just be kind of familiar with it. It makes your life a little bit easier. So, the way you determine if something's prime or composite is you have to do the prime factorization. Prime factorization is you break it down into all the prime numbers. If it has more than 2 factors, it's composite. If it has exactly 2 factors, it's prime. Okay. Now, of course, I'm assuming you know how to do prime factorization here, but anyway, let's talk about relative primes. So, 2 numbers are relatively prime if they don't share any common factors. So like 4 and 9, neither of them are prime numbers, but compared to each other, they are what are called relatively prime, because they don't have a common factor other than 1. So 2 times 2 is 4, and 9 is 3 times 3, so they're relatively prime. That's just how it works. If they don't have any factors that are the same, relatively prime. So let's see an example of relatively prime. So let's talk about 27 and let's do 16. So the question might say, are 27 and 16 relatively prime? Okay. So the way you would do it is you take each of those numbers and you break them down into their prime numbers. So 27, well, that would be 3 times 9, right? So we're going to do prime factorization right here. Prime factors. Now 9 is not prime. 9 is composite. So 3 is 3, and then 9 itself is 3 times 3, right? Make sure you bring down the original one. So 3 times 3 times 3 is 27. Okay, now, maybe 2 times 8 is what you would start with. You might start with 4 times 4. Now 8, so 2 times 8 is 2 times 4, right? 4, not prime, so 2 times 2 times, and then, right? 2, 2. There we go. Now, you can see for sure, these are the prime factors of each. They don't have anything in common, so the answer would be yes, they are relatively prime. They don't have any common factors. Okay, one more example. Let's do 27 again and 12. Let's see if these 2 numbers are relatively prime. The way we do it again, do the prime factorization. So 3 times 3 times 3, we just did that for the previous example, right? Now, this is 3 times 4. I can actually stop. 4 is not prime. If I were to write it out, I guess it would be like this. But we can stop right here. Look, they have a common factor. So these are not relatively prime. They're not relatively prime because they share a common factor of 3. Anyway, hope this was helpful. Have a good day.